Dear students, welcome back to the video lecture of module number 5, Instrumental Methods of Analysis. In the previous video lecture, we come to know the discussion on instrumental methods of colorimetric estimation of copper. And let us move to the second instrumental technique for our syllabus that is atomic absorption spectroscopy. So let us discuss about content of presentation. It follows like this. Beginning with introduction, instrumentation, applications of atomic absorption spectroscopy, principle of atomic absorption spectroscopy, experimental method, advantages and disadvantages of atomic absorption spectroscopy technique. So beginning with introduction. So atomic absorption spectroscopy is a very common technique for detecting metals and metalloids in samples. As you know that the metal salts are present in the solution or any liquid component, or maybe in water, or maybe in soil, or etc. And also metalloids. Metalloids are the sample salts which are containing the metals like whose conductivity is in between conductors and the insulators. For example, you can take a silicon, germanium are the metals. There are semiconductors. The metal salts which are made by the such elements like which are showing the semiconducting in the metallic state. So such elements are what they have been analyzed by this atomic absorption spectroscopic technique. And it is very reliable and simple to operate and use this experiment. And it can analyze over 62 elements in the periodic table. And it also measures the concentrations of metals present in the sample. As I explained in the introduction part, the pink elements what I expressed in the periodic table, those all elements have been detected, and also the concentration of those elements, if they are present in any sample solution, can be identified by the atomic absorption spectroscopic technique. So let us begin with the instrumentation of atomic absorption spectroscopy. So here I would like to discuss about 5 important components what have been used in the atomic absorption spectrophotometer. So the first one is the hollow cathode lamp. This is what the hollow cathode lamp. Then second one is the nebulizer. This is what the portion is called nebulizer. So from which we are able to supply the sample to the flame. Then atomizer is a part of the instrument or flame system where the liquid component is converted into the form of a solid residue. That solid residue decomposes to form the gaseous state. In the gaseous state, the elements are what dissociated in the form of atomic state. So that part is said to be the atomizer. Then fourth component is what the monochromator. This is what the most important part of this instrument. So what it does, it will allow the particular wavelength of light radiation by absorbing the other unwanted light radiation which are transmitted from the flame. Then the fifth component is what the detector. It identifies the signals of light intensity which are coming from the monochromator are magnified and are converted in the form of electrical signals, and those electrical signals have been fed on the computer system or the plotter or the data collector. From that we can come to know the reading of the particular element present in the sample of the solution. So this is what just I have given the default of the important components which have been used in the atomic absorption spectrophotometer. Now this is what one of the important part that is called the hollow cathode lamp. so which is made up of the quartz and fire, which has the fire X body, means what is what the glass body, which has the two electrodes, the cathode and anode. So whereas the anode is made up of the tungsten filament, whereas the cathode is made up of the stainless steel cylindrical component is used in the hollow cathode lamp, so which is producing the light source when the electrical power is supplied to this lamp. So this is what the atomic absorption spectrophotometer instrument. So what you can notice that here you can supply the sample of the solution. This is what the nebulizer system. Here in this portion you have the hollow cathode lamp, where you are going to supply the what you can say light into sample. Here you have the flame source, and here you have the display system, so where you can note the readings. So the same thing, it is what I have shown. It is shown here. This is what the sample supply through the nebulizer. Here you have the flame. This flame is lighted by the supply of the gas from the LPG, and the light source is passed from the hollow cathode lamp through the flame system, or you can say monochromator, and then whatever the light is transmitted from the lamp, or we can say the hollow cathode lamp, from that lamp through the flame, that is what the light intensity is what magnified by the detector, and that information is fed on the display system in the form of the readings. So the same flame atomizer system, it is expressed very simply in this slide. What you can notice that the sample solution is fed through the flame system with the support of the nebulizer, or it is also called as atomic cell, where the light source from the hollow cathode lamp is what allowed to pass through the flame, and because of that the color of the flame is going to be changing. The color of the flame depends upon the sample of solution which kind we are using, and that is what supplying through the nebulizer system. And finally, that from the light source, whatever the light is absorbed by the elements present in the flame are going to absorb, and they are going to transmit the particular wavelength of the light radiation by the excitation from ground state to the higher state, excited state. So as a result, the light intensity is what produced, and that light intensity is what magnified by the detector, so which is going to give the readings. So let us discuss about the instrumentation part, what I explained in the brief form with the support of the diagram. So that's that part I'm going to discuss with the in sentence wise. The first one is the light source. This is what the hollow cathode lamp is most common radiation source in atomic absorption spectrophotometer. The cathode lamp decides the kind of the elements is to be used for the analysis, so which are I expressed from the periodic table. So that is what the most important part, and it is decided by the kind of the elements which is used for the analysis. And it contains the tungsten as the anode, and hollow cylindrical steel act as the cathode. Made up of this element is used in the hollow cathode lamp, and this tube is sealed with the inert gas, that is called the neon or argon, and each element has its own unique lamp which is to be used for the particular elementary analysis. Then second part, that is what the burner system, which is not explained in the instrumentation part. As you know that the burner is the gas burner what you are using, which is producing the flame. When you supply the air and fuel from the LPG cylinder, air is from the atmosphere, fuel is from the LPG cylinder, which combines after lighting, the flame is produced by the burner. Then third component is what the nebulizer, which creates a fine aerosol spray for the introduction into the flame, mixing the aerosol and fuel and oxidant thoroughly for the introduction into the flame. And here the droplets, liquid droplets, are finally sprayed with the help of the nozzle, and those liquid droplets are what are going to form in the form of tiny particles. so which gets evaporated to form the gaseous residue, and those gaseous residues are going to decompose to form in the form of atomic state. This is what it has been done by the help of the atomizer. Here the atomizer, it plays an important role, as you know that generally the burners, what I explained, are work like an atomizer, so which is used to break the liquid sample in the form of the droplets, which are then allowed to enter into the flame. The droplets are then evaporated and the sample element is now it is left to in the form of residue, and that residue is immediately decomposes by the flame energy and is converted in the form of gaseous state. Thus in this process, those gaseous state atoms are what they are going to decompose to form the atoms, and those atoms are what are going to exhibiting from ground state to the higher energy state by the excitation by the flame energy. Then fourth important part is what the monochromator. This is the very important part of this atomic absorption spectrophotometer, and it is used to separate the thousands of lines which are observed in the flame. But this monochromator, what it does, it selects the particular specific wavelength of the light radiation which is absorbed by the monochromator, by excluding the other unwanted wavelengths which are not permitted to pass through that monochromator. And the selection of the light allows the determination of the light selected element in the presence of the others. It means the particular element has the particular monochromator. It will permit the particular wavelength of the light radiation for the particular element which is to be estimated, and unwanted radiations are what prevented by the passing through the monochromator. Now the fifth component is what is called the detector. The light is selected by the monochromator and it is directed onto the detector. That is typically we are using a photomultiplier tube, so whose function is to convert the light signal into an electrical signal proportionally. That light intensity is what directly proportional to the concentration of the metal salt which is present in the flame. The processing of electrical signal is fulfilled by the signal amplifier. The signal could be displayed for the readout system, or further it is fed into a data station for the printout by as per our requirement. Finally we can give the report by the detector regarding the sample information. Now let us discuss about important applications of atomic absorption spectrophotometer. So where we can use this instrument in our various field of chemical analysis. My dear students, this instrument can be used for the purity of the elements present in the sample for the various applications. So you can analyze even very small amount of the metals if they are present in the sample, like lead, mercury, calcium, magnesium, etc. So which are some of the elements which are not good for the environment, and most probably we are going to use this instrument for in concern to the environmental studies, like to decide the quality of the water or drinking water, to decide the quality of the ocean water, or to know that the salt concentration is how much in the ocean water, or to see the soil salt content, what it is used for the agriculture activity, whether the soil quality is good for the cultivation of particular crop. That is what we can decide it by the atomic absorption spectrophotometer. Not only this one, in food industries, whatever the beverages are going to be manufactured or the food items have been manufactured, so they contain some of the vital elements, where their elements are present in the appropriate range or not. That is what you can decide it by the atomic absorption spectrophotometry. And also in pharmaceutical industries, means in medicinal manufacturing industries are also very much important part of our life. So from the medicines we are going to get desired elements or desired components, so which is giving good health for the maintenance. So whether it is present in the appropriate range, that is what can analyze by the atomic absorption spectrophotometric technique. So these are the some few important applications of what? Atomic absorption spectrophotometer. So now in next video lecture we'll discuss about the experimental method of atomic absorption spectrophotometer. Thank you one and all.